Acha. So now what you're going to learn is relative position of object and image in convex mirror. Relative position of object, relative position of image, relative position of image with respect to object. That means where the object is situated. Okay, in a convex mirror. In a convex mirror. In this topic, what you are also going to study is okay, the first thing you are going to study is the position of object and image, then the type of image, that means virtual or real type of image. Okay, then orientation of image, that means the image is erect or inverted. Orientation of image and magnification of image. Magnification of image. Okay, case of convex mirror is going to be really simple. See, okay, suppose the object is at infinity. That means when I'm making the object very large, what I'm trying to say is that parallel rays of light are incident on the mirror, and after reflection what happens? This parallel rays of light after reflection will go on this direction, will reflect back to this direction, and this ray of light will reflect back to this direction, and the virtual image will be formed at focus. Okay, for an object which is at infinity, a virtual image would be formed at focus. For let me write down the sentence. For object at infinity, for object at infinity, okay, virtual image, virtual image would be formed at focus. Acha, the image is virtual, the image is also diminished. Diminished means point image is formed for a very large object, or point image for a very large object. Very large object. Understood this one? Okay. Now, what happens when you move the object? See, for the first time, I'm decreasing the size of the object and I'm moving it closer to the mirror. What happens to the image? See, as I'm moving the object towards the mirror, the image moves from the focus to the pole. Okay, okay, and see what happens. As I now look at the size of the object, the size of the object will remain constant. And as I shift this object towards the mirror, the image will also shift towards the mirror. But as the object of same size shifts towards the mirror, the image will get enlarged and enlarged towards the pole. Okay, so for any object between infinity and pole, infinity and pole, the image would be formed, the virtual image. Virtual image means the opposite side of the mirror. The virtual image would be formed would be formed between the virtual image would be formed between focus and pole. Focus and pole. Okay. Now one more note to write out here. Okay. The note is as the object of same size moves from infinity to pole. Okay, the image moves from focus to pole, focus to pole with increasing size, with increasing size. Okay, that means at infinity our image is at focus, at the object is at near the pole, our image will be near the pole. And see, when the object is exactly situated at the pole, no, the image will also be situated exactly at the pole, and the height of the object and the height of the image will be exactly equal. Okay, so from infinity to pole, image moves from focus to pole, and the image is always virtual erect. Erect means the orientation of the image. If the object is outward, the image will also be upward. In entirety of convex mirror, the orientation on object and orientation of image is always same, because all of our images are virtual. Orientation means inverted or erect. Orientation of object and image are same in case of convex. In case of convex mirror. Case of convex mirror. Okay. Now what we are going to study is about the parameters of image formed by the spherical mirrors. That means what are the parameters? That means the type of image, the orientation of image, either the image is virtual or real, or the magnification of the image. Okay. Parameters of the image formed formed by a spherical mirror. Okay, parameters of the images formed by a spherical mirror. Now there are specifically four types of parameter we'll study. Okay, first one is nature of image. Nature of image. Nature of image means either the image is real or virtual. Real or virtual. Okay, acha. So just make a rule of thumb, or just know a rule of thumb. See, you haven't done anything about lens, okay, but just understand a rule of thumb. Okay, for reflecting device, that means any type of mirror, either spherical mirror or flat mirror, any type of mirror. Okay, if image and object are on the same side, on the same side of the device, same side of the device. Okay, that means either both image and object are front of the mirror, or either both image and object are behind the mirror. So for reflecting devices, if the image and object are on the same side of the device, either both either both are real or both are virtual. Okay, that means the nature of image will be same as the nature of object. I What I mean is the nature of nature of image will be same as the nature of object. Nature of object. That means if the image is real, the object is real. If the image is virtual, the object is virtual. And vice versa. If the object is virtual, the image is virtual. And if the image is real, the object is real. If they're on the both side of, if they're on the same side of the mirror. Okay. And the principal rule of thumb is anything that is any or anything that is behind the reflecting surface. That means that is behind the mirror. Okay. Anything that is behind the mirror is virtual. Any object or image behind the mirror is virtual. Okay, one more note after to send out here. Acha. Acha. The second type of thing we'll study, or second type of parameter we'll study is mm, orientation of the image. Orientation of the image. That means the image is real or sorry, erect or inverted. Erect or inverted. That means what happens is in mirror sometimes what happens, or in mirror or in lens what happens is the image that is obtained by the mirror gets or gets inverted. Suppose the image is or object is like this. Okay, suppose the object is like this, the image will form with the head in the downward direction if the object has a head in the upward direction. Okay, so this kind of image are called inverted image. And sometimes what happens is this is a mirror. If the object and image have head in the same direction, they are called to be erect images. Okay, now one more thing to note out here also. In all optical devices, in all optical devices, okay, in all optical devices, if the nature of nature of image and object, nature of object and image are same. That means if the object is real and the image is real, or if the object is virtual and the image is virtual, then they will have opposite orientation. Will have opposite orientation. What do I mean by that is, that means opposite orientation means if the object is upward facing, the image will be lower facing, or if the image is upward facing, the object would be lower facing. Okay, the third parameter we are going to write is the magnification of image. Magnification of image. Magnification of image is nothing but given by m, where m is equals to height of image divided by height of object. So there are three parameters we learned: nature of image, orientation of image, magnification of image. Okay, and the fourth parameter we're going to learn is distance of image, distance of object and image from the pole. Distance of object and image from the pole. Okay. Now this magnification is given by magnification formula. This magnification of image is given by magnification formula that we are going to learn in the next slides or next topic. Magnification formula. And the distance of object and image from the pole is given by mirror formula. Okay, distance of mirror object and image of a spherical mirror, either concave or convex, is given by a mirror formula, or is given by the mirror formula. Okay, the next topic that we are going to learn is mirror formula and magnification formula. Okay, so what you are going to learn out here is mirror formula and magnification formula. So first thing first, we'll start with mirror formula. Mirror formula. Okay, first let us understand the mirror formula, then we'll derive the mirror formula itself. Okay, okay. Now suppose there is a mirror out here. Let this be concave mirror. This is the principal axis. Out here is the focus, out here is the center, and focus is half the distance from center to pole. Okay, the mirror formula is given as 1 by v plus 1 by u is equals to 1 by f. Okay, and what do I mean by 1 by v plus 1 by u is equals to 1 by f? See out here. Okay, v is nothing but the, suppose there is an object out here, object, and this object has an image somewhat out here, image. V is nothing but the distance of image from the pole. Okay, u is nothing but the distance of object from the pole, and f is nothing but the distance of focus from the pole. Now while solving for mirror or while doing mirror formulas, one thing you must always keep in mind, that in mirror formula you have to use our direction or convention of direction very carefully. So if this side is positive, this side is negative. So in this specific case, the value of u is minus u. Out here you have to put minus some value. The value of f is minus, and the value of v is also minus. See, you might have a confusion, sir, where to take a plus and where to take a minus. That I'll show you, or the sign convention I'll show you as I proceed on with the chapters. Okay, okay. Now the next thing that we are going to do is derivation of mirror formula. Achha, what we are going to do now is we are going to derive the mirror formula that we have just seen. So our current topic is the derivation of mirror formula, or the formula that contains 1 by v plus 1 by u is equals to 1 by f. Okay, so how do you derive this formula? So let's see. There is a mirror, there is a concave mirror. Now this concave mirror has a principal axis, fair and good. Out here is focus, out here is center. Okay, now suppose a object is out here, object, and the image is out here, image. Okay, okay. Now how do I prove that the distance between object, this distance, 1 by this distance, okay, plus 1 by this distance is equals to 1 by this distance. Okay, before proving those distance, let us calculate. Let us draw few ray diagrams. Okay, Acha. How will this image, how will this object form an image out here? Let us see. Okay, the first ray goes straight parallel to the mirror. Sorry, parallel to the principal axis and goes out here. Okay, this is our first ray. And the second ray goes to the pole and bounces back with an equal angle. Okay, angle of incidence is equals to angle of reflection. And both the arrow converges out here. So this is the real image out here. Okay, now we need to pay carefully attention to two more things. I'm joining a line of image and object through C. Okay, okay. Now I'm calling this object as A dash and image as B dash. Okay, now see this triangle. This triangle. Acha. The yellow dotted line was very unclear, so let me draw one more line so that you can see it properly. Acha. Let's see this triangle. Triangle AA dash and triangle BB dash C. Triangle AA dash C and triangle BB dash C. Okay. From similarity of triangle, from similarity of triangle A dash C and triangle B dash C. Instead of using the word triangle, let me just use a symbol delta. It's much better. Okay. From similarity of this triangle and this triangle, can I say A by A dash, sorry, A dash divided by B dash is equals to AC divided by CB, because these two triangles are similar. So this length divided by this length is equals to this length divided by this length. So can I say A dash divided by B dash is equals to AC divided by CB. This is our equation number 1. Okay. Now see two more triangles. This triangle, triangle A dash and pole. Achha, let's name the pole as P. Triangle A dash and P. Okay, and B dash and P. And these two triangles are similar. This triangle A dash and P and B dash and P are similar triangles. So from similarity of triangle, from similarity of triangle, instead of writing the word triangle, let me just model A dash and P and triangle B dash and P. Can I say the same thing? A dash by B dash is equals to AP divided by BP. Okay, A dash divided by B dash is equals to AP divided by BP. Okay, this is our equation number 2. Now see this both equation properly. A dash by B dash, A dash by B dash is equals to AC by CB is equals to AP by BP. So combining equation, these two equation number 1 and equation number 2, can I successfully say that AC combining, let me write them properly, combining equation 1 and 2, 1 and 2, we can properly write that AC by CB is equals to AP by BP. Okay, this is our main equation from which we will derive the mirror formula. Achha. Now see out here. What is AC? AC is nothing but this much distance. So AC is nothing but AP minus CP. So AC is equals to AP minus CP. Similarly, CB is nothing but CP minus BP. So CP minus BP is equals to CB. Okay. So if I transform or if I substitute these two values out here, can I say AP minus CP? I'm substituting AC by this value, AP minus CP. I'm substituting CB by CP minus BP. Okay. AP minus CP divided by CP minus BP is equals to AP by is equals to AP by BP. Okay. Is equals to AP by BP. Yeah. Okay. Now check the things out here. What is AP? AP is nothing but the distance of the object from the pole, or AP is equals to U. What is CP? CP is nothing but the radius of the mirror. So CP is equals to R. What is BP? BP is nothing but the distance of the image from the pole. So BP is equals to V. So if I rewrite this equation, substitute all this value AP by U, CP by R and BP by V, can I rewrite the equation as U minus R divided by R minus V is equals to U by V. Okay, and if I cross multiply them, V into U minus R is equals to U into R minus V. Now let us expand, or UV minus VR is equals to UR minus UV, or 2UV is equals to R U plus V. Okay, or 2 by R is equals to U plus V divided by UV. So can I say 2 by R is equals to, if I simplify this U plus V divided by UV, can I write 1 by U plus 1 by V? So this is nothing but our mirror equation. See, we already know, or we know that R, or radius of the mirror, is twice of focus. Okay, R is equals to twice of focus, or 2 by twice of focus is equals to 1 by U plus 1 by V. And if we simplify, if we cut the 2, we get the mirror formula is 1 by U plus 1 by V is equals to 1 by F. This is our mirror formula that we have derived. Mirror formula. Okay, now the mirror formula that we have obtained is nothing but 1 by v plus 1 by u is equals to 1 by f. So suppose there was a concave mirror, this was f, this was c, okay, and object distance was known as u, image distance was known as v. This is nothing but image, image, and focal distance was known as f. And you get the formula 1 by v is equals to 1 by u plus 1 by f. See, if we suppose in competitive exam, okay, there's not much time to derive or use this formula or derive the entire thing. Suppose sometimes they'll give you u and v, they'll ask you the focal length. Sometimes they'll give you focal length and u, they'll ask you the image. Sometimes they'll give you u and focal length, they'll ask you the image. So by simplifying this formula, we just find out each of the variable provided the other two are given. So focus is equals to uv by u plus v. Okay, when image position is asked, image position is nothing but uf by u minus f, and object position is nothing but vf by v minus f. Okay, now one important thing to note out here. Okay, mirror formula, mirror formula must always be used with sign notation, with sign notation. Mirror formula must always be used with sign notation. What do I mean mirror formula must always be used with sign notation? That means while using mirror formula, you have to take one side positive and the other side negative. Either you can take this side positive and this side negative. So how to take the sign convention we'll learn on the next slide. Okay, but just remember while using mirror formula you always have to take care of the sign convention, and this out here is the mirror formula. Okay, okay, now what we'll try to learn is the sign convention used in mirror formula. Sign convention used in mirror formula. Just note that while we have derived the mirror formula only for concave mirror, the mirror formula is valid both for convex mirror and concave mirror. Okay, so suppose this is a concave mirror. Okay, and this is our object position. This is the distance of the object from the pole. This is our image position. This is our distance of the image from the pole, and this is our focus, and this is our distance of the pole from focus. And our mirror formula was 1 by u plus 1 by v is equals to 1 by f. Okay. Now sign convention means while using this formula, you have to take care of the sign. See, while dealing with sign in mirror coordinates, you can assign any direction. That means either this direction can be positive or this direction can be negative, or for the same diagram. Okay, you can apply this direction as negative and this direction as positive. But for a single numerical, okay, once you name the convention, okay, stick to that convention only throughout the numerical. Don't change the convention mid numerical. Okay, understood? Okay, out here was object, out here was image. Okay, u is equals to this one, v is equals to this one, f is equals to this one. See, I'm taking the formula by this convention. Okay, 1 by minus u plus 1 by minus v is equals to 1 by minus f. Okay, so 1 by u, I can take minus common out here. Okay, minus 1 by u plus 1 by v is equals to minus 1 by f, and both this minus cancel out to be plus. So doesn't matter whichever convention you take. Suppose I take this convention, 1 by u plus 1 by v is equals to 1 by f, the answer comes out to be same. If the answer is, see, outside, if the answer is positive in this case, that means the object is, or object or image or whatever you're finding out, is in the left hand on the side, and if the answer is negative, it is on the right hand side. In this, if you have taken up this convention, if the u is positive, okay, that means the u lies out here. If u is negative, u lies out here in this side of the mirror. If v is positive, it lies on this side of the mirror, and if v is negative, it lies on this side of the mirror. Okay, the focus is always on the front side of the mirror in case of concave mirror. Okay, and the back side of the mirror in case of convex mirror. Okay, so now let's look at the question. The object is placed on the principal axis of a concave mirror at a distance of 1.5 f, where f is the focal length. The image will be at, okay, so what the question is saying is, there is a concave mirror, okay, and this is the focus. Okay, now the object is kept at 1.5 times focus. 1.5 times focus. But here is the object of our concave mirror. The image will be at. That means what the question have done is, they have assigned this side as positive and this side as negative. So I can directly apply the formula. What is the formula? 1 by v plus 1 by u is equals to 1 by f. And if you are searching for v, v is equals to fu by u minus f. Okay, so v is equals to, what is f? F is plus f. U is 1.5 f divided by 1.5 f minus, the value of f is f, or v is equals to f into u by f minus, v is equals to 1.5 f square by 0.5 f, or f and f will get cancelled. So it's basically 5 divided by 15 divided by 5, or v is equals to 3f. V is equals to 3f. Our correct answer is option number D. Okay, v is equals to 3f. Let's see this question. Okay, an object is placed at a distance of 40 centimeter from a concave mirror of focal length 15 centimeter. That means there is a concave mirror of focal length 15 centimeter. Okay, and the object is placed at 40 centimeter. So this is our object. This is placed at 40 centimeter. Okay, now let's read further. If the object is displaced through a distance of 20 centimeter towards the mirror, that means new position of object is this one, object, and this one is 20 centimeter. Okay, the displacement of the image will be, that means what the question is saying is that this object will create some image out here. This object, the final position of the object, will create some image out here. Find the distance or displacement between initial position of the image and final position of the image. Okay, so this is our object of second position. So for initial position of object, for initial position of object. Whenever you are solving any optical lenses or mirrors, just always first assign a coordinate system. This side is positive, this side is negative. Okay, so v or image is equals to fu by u minus f, or initial position of image is equals to 15 into what is the position of image, 40, sorry, what is the position of object, 40 by 40 minus 50, or is equals to 15 into 40 divided by 25. 15 into 40 divided by 25. 40 minus 15 is 25. 3 is a 15, 5 is a 5, 8 is a, or is equals to 24 centimeter. So our initial position of the image is 24 centimeter. For final position of the object, for final position of the object, again we find v final or final position of the image is equals to fu by u minus f, or v final is equals to, what is the value of f, 24. What is the value of u? See, this entire length is 40, this length is 20, so how much is the remaining length? 40 minus 20, which should be equals to 20 centimeter, 20 centimeter from the pole. So 20, so v is equals to, the focal length is 15, the object position is 20 by 20 minus 15, or vf is equals to 15 into 20 divided by 5, by 3 is a 15, or is equals to 60 centimeter. Okay, now see, due to our initial position of the image, our initial image was formed at 24 centimeter. After we shifted the object, okay, after the object was shifted, the final image, okay, was formed at 60 centimeter. So effectively, how much is the distance of image shift by? 60 minus 24, 60 minus 24, how much is 60 minus 24? It is 36. So this distance is 36 centimeter, and the image moved this side, no, because this was the initial image and this was the final image, so the image moved 36 centimeter away from the mirror. Option number B. Now what we are going to study is about the magnification formula. Okay, magnification formula. What is magnification formula, or how do we use magnification formula? So before studying of magnification formula, let us see something. Okay, suppose this is a mirror. I'm taking a concave mirror, and this is the principal axis. Now suppose my object was out here. This object would form image somewhere around here. Okay, now notice one thing, the distance or the height of the object is lesser than the height of the image. That means what? My image is more magnified than the object, no? That means my this mirror is magnifying the image. Okay, so how much is the image magnified by? How do we find out those? So we find out those by using magnification formula. In magnification formula, you need few parameters. U, where U is the distance of the object from the pole. V, V is the distance of the image from the pole. Okay, H naught, H naught is the height of the object, and HI, HI is the height of the image. Okay, our magnification formula says is that magnification is equals to height of image by height of object, which is equals to minus V by U, or distance of the image from the pole divided by distance of the object from the pole. Okay, And note one more thing, while using magnification formula also take care of the sign convention. That means if you do outside positive or right hand side positive, left hand side should be negative. Now I'm going to tell you the importance of this minus. See, while using magnification, apply coordinate system axis to above the principal axis and below the principal axis also. Okay, upward is positive and downward is negative. That means if my object, the value of u is positive, okay, and the value of v comes to be minus, that means my image is situated downward. Okay, and if the value of v comes to be positive, that means my image is situated upwards. So while using magnification formula, assign the coordinate system of upward and downward also. Okay. Hmm. Where let's label them, where m is the magnification, okay, hi is the height of image, height of image, h naught is the height of object, height of object. Okay, v is the distance of image from pole, distance of image from pole, where u is the distance of object from pole. Okay, now few remarks out here. Remarks means what does magnification or what does different values of magnification mean. Okay, so if out here m is greater than 1, that means the image is enlarged, image is larger than object, or image is enlarged. Okay, if m is equals to 1, that means image is same size as the object. And when does that happen? That happens when the object is kept at center of spherical mirror. That means when the object is kept at radius, image is same size as object. Okay, and when m is lesser than 1, that means what does it mean? Image is diminished. That means image is smaller than the object, image is diminished. Okay, up till now what you have studied is longitudinal magnification, lateral magnification. That means the object was kept, okay, the object was kept perpendicular to the axis. Okay, now what happens if the object is kept along the axis? That means suppose this is the mirror and this is my principal axis, and my object is kept like this. This is the object. Okay, where and how much by how much magnification is the image formed. Okay, so to study this, we study this in a topic of longitudinal magnification, longitudinal magnification by a spherical mirror, longitudinal magnification by a spherical mirror. Okay, now let this much distance be thickness of image. Okay, this much distance be thickness of object. Okay, mind you, okay, this distance and this distance is very small when compared to this distance or this distance. Why? Because if this is much larger, you have to take two separate value of u and find out two separate value of v, then find out the magnification instead of using this formula. Okay, so let this be u. Okay, let this be u, and let this be v. Okay, now we know by mirror formula is 1 by u plus 1 by v is equals to 1 by f. Okay, now what you are doing is I'm differentiating this u with respect to du and v with respect to dv, and focus of a mirror is always constant, so the differentiation of this focus would be constant. So differentiation of this focus would be 0. Okay, what I'm doing here now here is u inverse plus v inverse can be written as f inverse. See, I'm writing the same formula, or d of u inverse by du into du plus d of v inverse by dv into dv is equals to d of f inverse. See, f out here is a constant, so constant or in differentiation of any constant is equals to 0. Okay, so when I differentiate this one, the differentiation of u inverse would be minus 1 by u square du minus 1 by v square dv is equals to 0, or out here minus 1 by u square du is equals to 1 by v square dv. Now what is du and what is dv out here? Du is nothing but thickness of the object, and dv is nothing but the thickness of the image. Okay, see, v dv, u du. Okay, or out here can I say dv by du, is equals to minus v square by u square. Okay, and this is nothing but longitudinal magnification. Okay, so what do I mean by this is longitudinal magnification is dv by du is equals to minus v square by u square, which is magnification longitudinal, which is also equals to thickness of image divided by thickness of object. Okay, which is equals to minus m square or lateral magnification square. See why? Acha. V by u is nothing but the out here v by u is nothing but the lateral magnification, that means magnification perpendicular to the axis. So minus v square by u square, the magnitude of minus v square by u square would be twice the magnification of the lateral magnification. Okay, what we're going to learn is the velocity of image on a spherical mirror. Okay, so velocity analysis of image in a spherical mirror. Velocity analysis of image formed by a spherical mirror. Okay, acha. So situation is, suppose this one is a spherical mirror. Okay, you can take any mirror, concave, convex, both. This is my principal axis, this is my focus, this is my radius. Okay, or center or radius is equals to twice of focus. Now out here, suppose some object was there. Okay, suppose an object was there. Now this object was moving with velocity v. Okay, now my question is, if the object is moving with velocity v, okay, find the velocity of image. Okay, To find out the velocity of image, we must use the concept of magnification. See, this velocity can be componented into lateral velocity or velocity perpendicular to the axis and longitudinal velocity or velocity parallel to the axis. Okay, so this velocity of the object, velocity of the object can be componented into two categories. Okay, velocity of object laterally or perpendicular to the axis and velocity of object parallel to the axis. Okay, now for velocity that is perpendicular to the axis, we use lateral magnification formula. Lateral magnification means the magnification found perpendicular to the axis. The magnification found perpendicular to the axis. We use lateral magnification formula. Okay, so what does lateral magnification formula says that lateral magnification is equals to minus v by u is equals to height of image by height of object. Fortunately, this is also equals to velocity of image lateral to the axis or velocity of image perpendicular to the axis divided by velocity of object perpendicular to the axis. So out here, okay, out here using this formula we can directly say that velocity of image perpendicular to the axis by velocity of object perpendicular to the axis is equals to minus v by u, or which is equals to magnification. So velocity of image is equals to magnification into velocity of object. Okay, and now for the second part of the velocity, that means for velocity parallel to the axis. For velocity that is parallel to the axis, we use longitudinal magnification formula. Longitudinal magnification formula. So what does this mean? This means is that, see, thickness of object, or sorry, thickness of image by thickness of object is equals to minus v square by u square, which is equals to m longitudinal, which is fortunately equals to velocity of image parallel to the axis by velocity of object parallel to the axis. Okay, so using these two formulas we can simply write velocity of image parallel to the axis divided by velocity of object parallel to the axis is equals to minus v square by u square. Okay, and using this we solve our formula. So see, if you understand it dynamically, okay, out here if the object moves upward, the image will move upward by magnification formula, no? The image will move downward by magnification formula. Okay, but height of image divided by height of object is equals to magnification. Similarly, if the body moves right or left, the image will move left or right, and that is also given by longitudinal magnification. Okay, so magnification formulas are also used to find out the velocity of image in spherical mirrors. Okay, just make this take care of this. Okay, for velocity perpendicular to the axis or lateral velocity, okay, use lateral magnification formula where minus v by u is equals to height of image divided by height of object, which is equals to velocity of image perpendicular to the axis divided by velocity of image perpendicular to the axis, but velocity of object perpendicular to the axis. For velocity along the axis, we use longitudinal magnification. For thickness of image by thickness of object is equals to minus v square by u square, which is equals to velocity of image along the axis divided by velocity of object along the axis. Okay, and by combining, final velocity of image is equals to combination of velocity of image perpendicular to the axis plus combination of image parallel to the axis. Okay, so let us solve a question regarding magnification. Okay, match the corresponding entries of column 1 with column 2. Okay, m is equals to 1. See, up till now we have understood that a convex mirror can never form a real image. Okay, and whenever object and image are real in your entirety of optics, they will always be inverted. That means if the object is like this, the image would be like this. Okay, whenever the object and image are real, be it spherical lens, be it any kind of lens, or mirror, any kind of mirror, if the object is straight, the image will be inverted. Okay, so m is equals to -2 can never be for convex mirror. Why? Because convex mirror can never form a real image. So a, see out here, a goes to a goes to b. Acha, a goes to a goes to b. Acha, this is not possible. Why? Because minus value can never be for convex mirror. Acha, a goes to a, also this can never be. Why? Minus value can never be for convex mirror. Okay, a goes to c. Acha, a goes to c. Yeah, real image consists of negative value. B goes to b. That means out here b -1 by 2 goes to convex mirror. Can be. Okay. C goes to b. C plus 1 by 2 can be. Acha, can be. A concave mirror can have virtual image when the object is from focus to pole. The virtual image is from infinity to pole. Okay, it can be. And D, A and D, that means plus 1 by 2 A and D virtual image, it can be. Acha. Option number A to B, option number A, B. Acha, it can be real. Concave mirror can have real image. B to B, -1 by 2, it can be real. B and C. Acha. C to B, C to B, it can have real image. And D plus 1 by 2 to A and D. Okay, so between these two options I have to evaluate. Okay, so option number A, C and D out here. Option number A, C and D. Achha, one cannot be virtual and real image at the same time, no? So this is by fault cannot be valid option. So correct option is option number D. Okay, so the remark out here is, so the remark I have here is, let's write the remark. The correct option was option number D. Okay, the remark I have here is, if m is negative, that means the object and the image are inverted with respect to each other, with respect to each other. Okay, and in any optical device, be it plane mirror, be it optical lens, okay, whenever the objects are inverted with respect to each other, that means both the object and image are of same nature. Okay, so that means if the object is virtual, the image is virtual. If the object is real, the image is real. So whenever in any optical device means be it lens that we are going to study or be it the mirror that you are studying currently. So whenever in any optical device, so whenever in any optical device, the object and image are inverted with respect to each other, with respect to each other. So whenever in any optical device the object and image are inverted with respect to each other, okay, both the object and an image are of same nature. Both the object and image are of same nature. That means if the object is real, the image is real, and if the object is virtual, the image is virtual.